Hello and welcome to the review for chapter 5. There's going to be a couple of videos for this and you'll see me kind of skipping around. There's some of the problems that I'm going to skip because we didn't cover them in class. So here we go. I'm going to share my screen so that you can follow along. So one thing that is important to know about rational expressions and equations is we cannot allow our denominator to equal 0. So for the domain, it's all values except we have exclusions. So where this value equals 0, it's going to cause the denominator to be 0, and then the fraction will be undefined. So if we add 8 to both sides, and then if we divide by 2, we get this. And then if we take the square root of both sides, we'll find out that x would be a plus or a minus 2 would give us that issue. So those are exclusions. We cannot have x equal to plus or minus 2. Evaluating a rational expression when t equals 3. So this will be 2 times 3 squared minus 10 over 2 times 3 squared. So that will be 6 squared minus 10 over 2 times 9. And then we'll have 36 minus 10 over 18. And then that will be 26 over 18. And that'll reduce to 13 over 9. On the fraction, the graphs on 3 and 4, I am skipping. You're going to go down to 5 and 6. So when we are multiplying and dividing fractions, it's going to be looking at if we need to factor first. So because anytime you have an exponent of 1, you don't need to factor. It's been factored enough. But if there is a term that has a 2 or bigger, then we have a possibility of factoring. So I'm just factoring each of the pieces, the numerators and denominators first. And I'm not going to go into how to get them each factored because that's something you should have been working on already just to save time on the review. And then this one, to switch it around, I'm going to factor out a negative. So this is x squared plus 2x minus 3. So this would be a negative 1. And then we'll have an x plus 3 and an x minus 1. And then the x minus 1 will cancel, x plus 3 will cancel, x plus 2 will cancel. And it looks like I just have this negative 1 here. So negative 1 times x plus 1. Then when I'm dividing, before I do any factoring, I'm going to go ahead and flip over and turn this into a multiplication of the reciprocal of the second fraction. And then these a's can cancel. So I have 1 over b times, I can factor out a b here. And so a b will cancel there. And it looks like we're left with a plus 1 over b. So on this one, we're going to go ahead and factor this. So this will be 3 minus a, 3 plus a, and then a plus 2 and a plus 2. And remember, we have to flip that around because this is dividing. And then here, I'm gonna factor out 6, so it's a squared minus 6 minus a. So I've got 6, and this one is a minus 3a plus 2, and then 2a over 3a plus 2. Let's see what can cancel. So my a plus 2's cancel, a plus 2's cancel. 2 can go into this 6 3 times. And then I'm gonna, this is 3 minus a. So if I factor out a negative 1 here, this will be an a minus 3. Then those can cancel. So I believe I'm left with a negative times 3 plus a times a all over 3 times 3, which is 9. In that one. That was pretty tricky with the multiplication and the division. So number 8 was a multiple choice that I kind of cut out. So the wording is weird. It says, which among the following is to be added to this to get to that? So it's more like, I'm just kind of seeing the connection here with the LCD. So I would need to multiply 5x. To get to this, I'd have to multiply by an x plus 5 over x plus 5. And then we'd have 5x squared plus 25x over the difference of squares. And then we'd have to add something to it to get to this, but just that's how we would get a common denominator. Okay, let's look at 9. 9 says if we have big A subtracting this equals this, then A equals what? So we would, if we add this to the right-hand side, we'll solve for A. So A equals a squared minus 10a over 2a squared minus 8 minus, oh, actually adding. So if we add that to both sides. So let's see here, minus 4. So this is really a difference of squares. Okay, so this is the common denominator. So this fraction here will stay the same, a squared minus 10a all over 2a minus 2a plus 2 plus a over a minus 2. So we need to multiply what's missing, which is 2 and an a plus 2 over 2, a plus 2. So we have a squared minus 10a plus, I'm going to multiply this through 2a squared plus 4a all over 2a minus 2a plus 2. So let's just combine these. So we've got a squared and 2a squared is 3a squared minus 6a all over that denominator. So I can factor out a 3a, and then I have an a minus 2 all over 2 a minus 2 a plus 2. The a minus 2's cancel, so we end up with 3a over 2 times a plus 2 equals the big A. So that's a tricky one. Okay, number 10, simplify the following. So we're going to get a common denominator. And before I can do that, I need to factor all of these and then a y plus 3. So it looks like my LCD is 2 y plus 3. So the first fraction is missing the 2 and the y plus 3. So 2 y plus 3 over the denominator here. And the second fraction has everything but just the y. So it's going to be a y times a y minus 3. And this fraction is just missing the 2. And distribute, so we've got 2y plus 6 plus y squared minus 6. It looks like those cancel out all over our denominator. And so then we have 2y plus y squared, so we can factor out a y. So we have y times 2 plus y all over 2y plus 3. So the only thing that cancels there, so it's really y plus 2 over 2y plus 3. Or you can leave it 2 plus y. That's fine too. We did not really cover the section that pertains to 11, 12, and 13, so I'm not going to do those. I'm going to skip to number 14 here. And because we're solving an equation, we're going to multiply through by the LCD. So we have x plus 2, we have an x plus 2 and x minus 2. So it looks like our LCD is x plus 2, x minus 2. So when we multiply by the LCD, we eliminate the denominator and then we only have remaining the factor from the LCD that was not in that denominator. So this fraction is missing the x minus 2. So I have x times x minus 2. And then this fraction is missing the x and x minus 2. So then we have 3 times x minus 2 equals, and then this fraction is missing x and x plus 2. Now we can go ahead and solve. So we have x squared minus 2x plus 3x squared minus 6x equals 5x squared plus 10x. So we have x squared and 3x squared. So that's 4x squared minus 8x equals 5x squared plus 10x. So I'm going to move everything to the right. And so when I do that, I'm going to subtract 4x squared. So I have an x squared. And I'm going to add 8 squared, 8x. So I have plus 18x. And so we have x times x plus 18. And so x can equal 0 or x can equal negative 18. And I think either of those will be fine because they're not going to cause an denominator with 0, which would cause it to be undefined. Okay, I'm not going to look at number 15. I'm not going to look at number 17 or 16 in that case. And I'm not doing any 18, 19, or 20. So that's all for chapter 5. So catch me back. That's all for chapter 5. Catch me back for the chapter 6 review.